As we navigate around the environment, we encounter a number of different obstacles. One example of this is gaps that are created by parked cars, by street furniture, by other pedestrians. If these gaps are smaller than we are, then we need to make some kind of movement adaptation in order to pass through without collision. In order to determine whether or not that type of action is needed, we need to be able to determine the size of the gap, the size of our body in relation to it, and then, if necessary, make those movement adaptations. Making error at any of those stages can result in collision and potentially harm. One population that might find this type of movement particularly difficult are individuals with DCD, developmental coordination disorder. Anecdotal evidence tells us that this population is particularly prone to colliding with obstacles in their pathway, but it's not clear why that might be. Is it a difficulty with judging the size of a gap or an obstacle? Is it difficulty integrating body size into a decision-making process? Or is it difficulty making that movement adaptation? The current paper focuses on, in the first experiment, the perceptual elements, judging absolute size and integrating body size information, and then in the second experiment, the movement adaptations. So essentially, in the first experiment, we asked children with and without DCD to make passability judgments. So in other words, would you be able to pass through this gap or this aperture without turning your shoulders? And when we compared our population with DCD against our typical population, what we found is that the children with DCD made smaller passability judgments, whereby they were saying that they needed less room to pass through an aperture than a similarly sized typical child. In the second experiment, when we integrated movement, and here we measured movement very precisely using an optical tracking system, we pretty much found the reverse finding, whereby the children with DCD now demonstrated that they needed more space to pass compared to a similarly sized typical child. So essentially here we've shown a complete reversal of results, whereas in the perceptual task children with DCD are indicating they need less space, and in the action or movement task they're indicating that they need more. We also ran correlations between the perceptual judgments and the action adaptations, and what we found was that the children with these showed a significant relationship, whereby a child saying that they needed a lot of space to pass in a perceptual task also demonstrated that they needed a lot of space to pass when we asked them to make the movement. And essentially this describes a very functional perception action cycle, whereby what is thought in a static context is realised in a dynamic context. And this is a very novel finding because previous studies that have looked at this within a DCD population have found this cycle to be dysfunctional. So in essence, what this paper has shown is that findings within a perceptual setting, even if it's a perceptual setting in the context of movement, may be very, very different than the findings within an action context within the DCD population. And within the paper, we advocate the use of the constraints-based approach to focus on perception within a movement context, but to also consider perception within a movement context without movement, but then also to consider it with movement, to look at what happens in both a dynamic and a static context. If you have any questions about this paper, please do feel free to get in touch with me.